In this lesson, we're going to look at electrical potential energy and electrical potential difference. To help us understand this, let's just have a look at this table. By the side of that, I've got a cannonball, and I'm going to increase the potential energy of the cannonball. Now, in this case, the potential energy is called gravitational potential energy. And to increase its energy, I just have to lift it up and place it on top of the table. What I've just done, in fact, is I've separated two masses. One of the masses is the cannonball, and the other mass is a huge, massive object called the Earth. By separating the cannonball from the Earth, I increase its gravitational potential energy, or its GPE. I can do a similar thing with like charges, for example a positive charge and a positive charge, but rather than separating them, I bring them closer together. And if I bring these two charges closer together, as I do that, I increase their electrical potential energy. Now, a device that does just that is the Van de Graaff generator. When I turn this on, the belt spins around here and causes positive charges to accumulate on the Van de Graaff dome. Now, what I'm doing is bringing positive charges close to each other, and as a result of that, I increase the electrical potential energy of the dome. We can call that the EPE. Okay, now I can do a similar thing, for example, with a balloon. By taking a balloon, if you take a balloon and rub the balloon against your hair, you will make negative charges, this time not positive, but negative charges accumulate on the surface of the balloon. And exactly the same thing happens. You're bringing like charges, negative charges, close to each other and causing the electrical potential energy of the charges to increase. A similar thing happens with a voltaic cell. When you immerse two electrodes, different electrodes, in an electrolyte, a reaction takes place which causes negative charges, like charges, to accumulate on the positive electrode. They actually accumulate at the positive electrode. As a result, you're bringing negative charges close to each other and the electrical potential energy increases. Now, the main difference between the three different accumulators, if you like, is in the voltage. Van de Graaff generator will acquire an electrical potential of something like 100,000 volts, whereas a balloon would be something like 5,000 volts, and your common AA cell will produce a voltage, an electrical potential at that terminal of only 1.5 volts. You might think wow, this looks really dangerous. Well, it isn't, because the difference between the Van de Graaff and the cell is that a very, very, very small amount of charge accumulates on this dome. Even though the electrical potential is very high, there's a very small amount of charge, likewise on the balloon, which means that it produces very, very small currents indeed, which are not going to harm you. Now, a cell or a battery may have a lower electrical potential, but there are far more charges and they are able to produce much larger currents. Now, I want to talk about electrical potential difference, and before I do that, I'm going to remove the balloon to give myself a bit more space. And what's actually happening in both of these cases at the moment is you've got charge accumulated here on the cell and here on the dome, but the charges aren't doing anything. They're stationary, we have to trigger something really in order to make those charges move. A little bit like this situation here with the table and the cannonball. In order to make the cannonball move, then what I have to do is make the table disappear. Okay, so I make the table disappear, click, and the cannonball will immediately start to move. How does it move? Well, it moves from always a higher gravitational potential energy to a lower gravitational potential energy. Now, in the case of the Van de Graaff generator, I'm going to do something to make these charges move. I'm going to bring a metal conductor close to this Van de Graaff dome. The metal conductor is connected directly to Earth, and that means it has an electrical potential energy of 0 volts. What I have done now is I've created an electrical potential difference, and it is the electrical potential difference which will make the charges move, and they will move always from a higher electrical potential to a lower electrical potential, just like the cannonball moves from a higher gravitational potential energy to a lower gravitational potential. Let's make a note of that. We have an electrical potential difference. This is commonly termed in your coursework as a potential difference, often abbreviated as PD. Okay, that's the potential difference between the dome here and the Earth conducting sphere, and that will cause the charges to move, and as a result you will see a spark form between the two domes. And as I said before, this isn't dangerous because the amount of charge that's jumping over from one to the other is very, very small indeed, even though it's at a high potential. Now, in the case of this AA cell, we stated that the positive terminal acquires an electrical potential energy of 1.5 volts. By default, the negative terminal acquires an electrical potential energy of 0 volts. Now, nothing will happen until we connect those two potentials. And so when we close the switch like that, because there is an electrical potential difference between the positive terminal and the negative terminal, then charges will start to flow always from the high electrical potential to the low electrical potential. So to finish, we can say that charge always flows from a high electrical potential energy to a low electrical potential energy, whether it's in the form of a spark jumping from one dome to another, or whether it's in the form of a current flowing around an electric circuit.